Hello class. In this video we're going to be learning about Docker, what Docker is and what it's used for, and also we're going to learn from scratch how to set it up and how to create images and containers, which we'll learn what they are, and also at the end we're going to see how to create an app that has multiple containers that talk to each other and works perfectly fine. Before we do any of that, what is Docker? So Docker is a tool that allows us to create things called containers. Now, what are containers? Containers, think of them like virtual machines. And if you don't know what that is, it's like a machine that is running as a piece of software on your computer or on a server, and it has its own environment separate from the host machine. So I'm on a Windows right now, and I can have a virtual machine that has Linux and some other dependencies and software that is not on my main machine. Now, there are some differences between containers and VMs. So actually, let me Google this. So let's say containers versus VMs, and there should be some cool images here. Actually, yeah, this one. So this is the main difference between containers and VMs. They're pretty much the same. The infrastructure is the same, meaning your computer or like a production server or whatever. And also here at the top is the same. Both will have binaries and libraries and your applications running on them. But the difference lies here in the middle. Each separate virtual machine requires its own guest OS that says here, which is an operating system. Meanwhile, containers don't. Containers run all on one operating system, and then the container engine manages the different environments and allocates resources properly. Now, this is the main advantage because obviously the operating system will take a lot of space and processing power, and also some other resource provisioning utilities that are hard to manage on different VMs, but a container engine, in this case Docker, makes this really easy. And by the way, if this is a bit too complex, don't worry. All of this is managed in the background. I'm just explaining the advantages of containers over VMs. Now, you might be thinking, okay, that sounds cool and fancy, but what is the use of Docker to a developer? So there are a couple of advantages. One of them is you can set up development environments really easy, like with one command. Like let's say, for example, I mainly work on Node.js apps, and then sometimes I have to work on a project that involves like using Django with Python. I can literally just have one command that pulls an image from the web that has all the dependencies for Django and Python, and then I could just run that one command and boom, I have a container that runs that environment, and then I can run any Python code or Django code on that container, execute it and develop it, and then once I'm done, I can just run another command which will remove that entire environment from my PC. So I don't have to install all of the software, and also I don't have to uninstall it at the end. Also, if you want to run multiple versions of the same piece of software, the same dependency, when you're developing, let's say you had like a piece of, like a library that required Node version 12, but you have on your PC Node version 14. You can just spin up a container that has Node 12 and then put that dependency on there, and then use it with your machine or with another container, and you can have them working both side by side. This can also be useful when testing. If you're making a package and you want to test it on different versions of the same library, you can spin up multiple containers with different versions of that library and then test it on all those containers on the same machine. And also you can make it really easy to sync up environments with other people. Like let's say you're working in a company and then you guys hired like a new developer, and then now you want that new developer to have the same environment as you because you don't want them to write some code and then push it to production and then it will fail because they're using a different version of some package, and then when they pushed it to production it failed, or if someone pulled the code it failed on their computer. You can literally just send them a Docker image or a Docker compose file, and they can run one command and they will have all the dependencies and the environment exactly the same as the other developers in that team. Now there are other advantages but I don't want to get too much into the theory. You know me guys, I like to teach by actually doing. I think that way you memorize and remember things the most. Alright, I might have lied when I said from scratch because I already have Docker installed. You can install it yourself, it's really easy. Just click on get started in docker.com. And here download it depending on your system. I'm using Windows, so I downloaded that and I just installed it. I think at the end of the installation of Docker, it's going to ask you to enable Hyper-V and containers, and I think it's going to give you a pop-up and you just click yes and that will be done automatically. If not, you can always go to, turn Windows features on or off, and you can enable Hyper-V here. Alright, so you can pause the video, install Docker, and then come back when you're done. Alright, now that you installed Docker, we can actually start to use it. But before we start to use it, there's one important thing that you need to do, which is to hit like on this video so that it gets out there and more people get to learn Docker. Thank you. All right, let's go to the terminal. Okay, so here in my terminal, to test that Docker is running, And by the way, when you start it, you're going to get this system tray icon. Yeah, this one. And if you double click on it, it's going to open this Docker desktop GUI. But we're not going to use the GUI, we're going to use the terminal. It's just good practice to get used to the terminal, because sometimes you're going to be on your server and you're not going to have access to a GUI and you're going to get stuck there. So in the terminal, just to test that Docker is up and running, you can just type Docker and hit enter. And it should bring up all of these commands, which means that Docker is up and running. So to get started with something that can be a good example on how Docker can be useful is, let's say I want to use Node.js, and I'm going to be using Node.js because I'm sure most of you guys will be familiar because of the type of stuff that I publish on this channel. So let's go ahead. I'm going to Google something. I'm going to Google Node Docker and hit enter. And we're going to get this link, hub.docker.com. Similar to GitHub, this is where people put their Docker images and share them with other people. And this is where you can get some useful images to use for yourself, or you can as well upload stuff here, just like in GitHub. So here I'm in this node page. Here it's telling me I can run docker pull node, which pulls the image. And if you scroll down, you can see all of these different tags, which are different. They're different versions of Node in this case, and also different Linux distributions here, which don't worry about them too much. I'm just showing you here, if you want to pull a specific version, you can just pull one of these. So let's go back to the terminal and let's run that command. Let's say docker pull node and hit enter. And now it says it's using a default tag latest. And now it's pulled this image, and we can see the images that we have by saying docker images. And there we go. So I have a couple of other images because I do actually use Docker as well. And here we have this node image with the tag latest. Before we carry on, I want to quickly explain what images are. So basically, an image to a container is what a blueprint is to a house. So when you have an image, you can spin up as many containers as you have. Same thing when you have a blueprint of a house, you can build an entire city full of houses of the same design based on that blueprint. So an image is what's important, is what you share with other people, and then they pull the image and then create a container based on that image, which is a piece of software that runs whatever there was in that image. And you can check which containers you have by running docker ps. And this will show you only running containers. So if you want to see all the containers, even the ones that are not running, you can say docker ps-a, or you can use also a different syntax by saying docker container ls. Both work just fine. And of course you can use -a for this as well. And now we can run that node image by saying docker run node and hit enter. And it actually just exited because running node doesn't do anything. It created this container, but it instantly exited, as you can see here. Now you can say docker run and do --help to see what flags that you can use to have different operations. We can say docker run -it, which allows us to plug into the terminal straight away after running it. And now we can say node. And there we go. We're inside a node terminal. We can say console log and say hello world. And there we go. Now notice the difference. Here we have node 15.10.0, and if I open a new terminal, so this will be on my machine, and I'll say node-v, you see that I have 14.15.5. So you see, indeed, I'm in a different environment with a different node version. And even if I didn't have node on my machine, I would have been able to have this terminal and have this container run node just fine. So let's exit out of here. And now let's create an example app to show you how you can run an app on a container. So here I have this folder called Docker tutorial. You can create any folder, and I'm going to create a file here. I'll call it server.js. And here this will be a very basic Express app. So here I'll say const. Actually, let's install in this directory. Let's install npm install express. I'm showing you an example while installing dependencies. Even though you don't need to do this, you can just have a package JSON. Actually, let's say npm init-y, so we can have a package JSON file. And in this server.js, it's just going to be a basic app. So we'll say const express equals require express. And we'll do const app equals express. And we'll have just one route, and we'll say app.get / and we'll say request response. And here, this will just say res.send, and it will send hello world with exclamation mark. And here we'll say app.listen, and we'll listen at port 5000. And then once the server starts, we're just gonna console log and say server up on port 5000. Save this, And we can run this just to test it, node server.js. And there we go, we get port 5000 printed, and we can say in a different terminal, curl localhost 5000, and we can get hello world. All right, so how can we put this in a Docker container? Easy. We're going to create a file in this directory. So a new file, and we're going to call it Docker file. And it doesn't have an extension. So a Docker file is like instructions for Docker to build an image. By the way, you can get the extension. So you can go to the marketplace and get the extension called Docker for VS Code. And this will give you syntax highlighting and also suggestions here in this file, and also give you this tool here that allows you to start and stop and manage containers and images from inside of VS Code, which is pretty cool. I mainly use it for the syntax autocomplete and highlighting in the Docker files. All right, so I'm going to close these. So here we need to say at the beginning, we're going to say from, and from usually takes a base image. So we want to base this image on the node image. So we're going to say node, I'm going to do colon and say 15. So what's after the colon is the tag, and I want to use version 15. And then here next, we're going to say workdir, which sets the working directory, which usually is /app, which creates a folder inside the container and navigates into it. It's because we want to put everything in this /app. So we say this. Now, next thing, I want to copy everything that's here into the container, so I'll be able to run it from there. So we can simply say copy, and you can say dot and space dot. And if you find this syntax a bit confusing, you can just say dot slash. This works as well. And what this does is it copies everything from here to /app because we set it as the working directory. And now when we copy the files, we want to start our server. So we can do this using something called cmd, which allows us to run a command when the container is created. And here this command will say, it will be running the server.js using node, so it will be node server.js, but here we're going to say node in one string, and then next to it we're going to put another string in the array, and this will be server.js. So this is the syntax for this, it's just going to run node server.js. So let's save this, and now we need to build this. And to build this in the terminal, let me close this, in the terminal in the same directory where we have this Docker file, we can say docker build dot, and when you say dot, it's going to look in this directory, look for a Docker file, and if it's different, you're going to use a flag -f and give it the name of the file. In this case, it's Docker file, so we can just say dot, and we can say --tag and give it a tag to give it a name. I'm just going to call this node-server and hit enter. And now that's finished. As you can see here, you have a couple of instructions. You have this from Docker, which is from that image, the base image, and then you have, so 1 out of 3, and then 2 out of 3 is setting the work directory, and then 3 out of 3 is copying. So it's going through the instructions in the Docker file and putting them in different layers inside the container or inside the image. So now that's created, you see we get an ID here, and we can copy this ID, and we can say Docker. Actually, we don't need to copy this ID. You can just say Docker images, and there we go. We get our node server image. So now let's start it. So we'll say Docker run. So to run a container, we need to give it the image, which in this case is node-server. And notice it's the exact same syntax that we used to run the node image from the cloud. By default, when you say Docker run, it's going to look in your machine, and if it doesn't find it, it's going to look on the cloud. In this case, we have one on our machine, so it's going to run our image. And here at the beginning, I'm going to give it --name, and we're just going to call it node server container for now, and hit enter. And there we go, we get server up on port 5000. And if we open a new terminal and say docker ps, we get this container that has the image node server, and here it has the name node server container and is up and running. But if we do curl localhost 5000, we're not going to get anything. And that's because containers by default are isolated. And this port 5000 is not open to the public. So we need to open it, and that's easy. So let's go back. Let me close this terminal. Let's go back to the other terminal, Control C to stop this. And by the way, when you stop it, so if you do docker ps-a, the container is still there. So let's actually delete it. I'll show you how to delete the container. So here, node server container, copy that. And then we can simply say docker rm for remove, and then paste that name and hit enter. Okay, it's still running. Okay, so we need to stop it. So here, let's say docker stop, and then give it the name of the container and hit enter. Okay, now we can actually delete it. So do docker remove node server container, and now that container is gone. So let's recreate it with the exposed port. So let's say docker run node server, our image, and now let's give it the same name. So --name node server container, or we can actually say app because they're all containers. And now let's expose that port. So we can simply do that by saying -p for port, and we're gonna say 5000 colon 5000. What does this mean? It means that this second 5000 is the internal port, which that app is running on. And this first 5000 is the port that is exposed to the public, which is what we are going to use to access this from other sources. And I'm going to add another flag here, say -d, which runs it in detached mode, which means when we run it, it's not going to hang and just stay like this and hold the terminal. It's just going to stop, or it's just going to like go away. So now if we hit enter, there we go. We get the ID and now it's running. And now if we do curl localhost 5000, we should get a response. And we indeed do get hello world. Cool. All right, let's say we want to update our code and rebuild it again. So that's easy. So I want to do something here. We can say const, or actually not const, we can say let count equals 0. And this will be a counter to show the user every time they visit. This is an example I saw on the Docker page, which is pretty cool. So here we'll say whenever someone requests the /endpoint, we're going to say count, increment it, so count ++, and then we're going to send back, and we're going to say here, do backticks and say, hello world, this has been visited, and then do $ curly brace and concatenate the count, and then say times, and remove that, make it backticks and save. And now to rebuild it, we can simply say docker build dot, and give it the same tag, --tag node -server. And there we go. Now it's rebuilt it. If we do Docker images, we get this node server, and the old image is now without a tag. So that's preserved in case you need it. And by the way, if you want to remove, let's say, an image, if you want to remove this one, you can either remove it by the repository name, the image name, or the image ID. So let's say when I remove this because we don't need it anymore, you can just copy this ID and say Docker. You can either say Docker image rm, or you can say RMI for short, which removes an image, and then paste the ID. Okay, I think there's a container that's using this image, so we're not unable to delete it. So let's say docker ps. Yeah, we have this container running, so we need to actually stop this container. And we're going to say docker stop and then paste the ID. And by default, it wastes 10 seconds to stop it. You can override this and say -t0, and that will stop it instantly. Okay, I put the image ID, my bad. We need to put either the container ID or the container name. So I'm going to take the container ID and then run this same command, but with the container ID instead of the image ID. Run that, and there we go, that's stopped. And now we can remove it, so docker rm and paste the ID. So now it's removed. We can actually remove the image. So let's take that image ID again and then say docker rmi and paste that image ID, and there we go, that image was deleted. So let's run a container with this new image, node server. So again, let's say docker run, and let's give it the name of node server app, and it's going to use the node server image. Important, the image needs to always be at the end. So again, we need to expose the port. So let's say -p 5000 colon 5000, oops, 5000. And let's also say -d, so it's detached and we can escape out of the terminal. So hit enter. There we go. So now if we say curl localhost 5000, we're going to get hello world, this has been visited one time. I should have been times, but whatever. So if we request again, we get 2, 3, and so on. All right, so our code has been updated and our image now has the new code. Now let's look at our Docker file. So here, this first part is fine. And then we're copying everything, which in this case includes the node modules, which is not ideal because it's kind of slower. We need to install the dependencies on the image itself. So that's easy. We can, after we copy everything, we can say run, and here we can give a command that runs what the image is being created. And here we can simply say npm install. And now to make sure that the node modules is not copied, we can create a new file here, a .docker ignore, very similar to get ignore. So here we're going to say node modules / and now it's actually going to notice and it's not going to copy the node modules. And let's also say docker file here because we don't need the docker file itself inside the image. So save that. And now let's rebuild it. So let's say docker build dot, and -t short for --tag, and the tag will be node -server. So run that. And there we go. Now you get 4 out of 4, run npm install, and cool. Now the image is created. let's stop this existing container. Yeah, let's docker stop node server app and do -t0, and let's remove it. So docker remove node server app. And now let's run a new container based on this new image. So let's say docker run again -p to expose the port 5000, and then colon 5000 -d --name. We'll call it again node server app, and the image is node server. So hit enter, and there we go. It's working exactly the same. So if we do curl localhost 5000, of course it's reset to 1 because that's not in a database or anything. We can also actually execute commands inside of our container. So for example, if we want to look inside the container what there is there, we can actually execute bash and browse the file system there. So we can say docker exec, which stands for execute, and we need to give the name of the container, which is node server app, and the command that we want to execute, which in this case is bash. And for bash to work, we need to give an extra flag -it, which basically allows us to open a terminal there. So hit enter, and now you see we're inside the container. If you type ls, you'll see that we have node modules and package.json and server exactly like here. And notice we don't have the Docker file because that's in the Docker ignore. So now we can run commands here, and we can also exit out of here. We can run commands just like standalone commands. For example, let's say here, actually without the IT, we can say, for example, want to see dependencies, we can say npm list and hit enter. And there we go. We have express, and we get some like notice here. So you can have actually a container that just basically has node, and you can use that container to run npm or node on a machine that does not have either of them. Now, let's say our app got a bit more complicated and we needed to use a database for our app, and we wanted to also isolate that in an environment. Now, you can put the database inside of the same container, but that's not recommended. Usually it's recommended every service should be in its own container so that it's more maintainable. You don't want to update the container that has the database engine every time you change the code, because those are separate things. So let's look into using multiple containers and have them talking to each other. So for this, I prepared a code base, so you can clone this. I'll put a link to this in the description. And this is just a simple app, a simple Node.js app that uses a Postgres database. So you can go ahead and take the link to this and clone it. So I'm actually going to delete everything here and clone this instead. So I'll say rm and just delete everything here. Actually, I'm just going to say -r. Cool. Okay, left out the .docker ignore, so I'm just going to remove that as well. So now I'm going to say get clone and paste that and clone it here. Say dot. I'm just going to walk you through this quickly. So we have an entry point server.js, which imports Express and Morgan, and then starts an Express app, which has these two routes for fetching users and for creating a user, and then it starts the app. And then we have this DB file here that starts a next, which is a query builder instance, and that connects to a database. And then we're going to use that database to manage our users. And then we have these two scripts here, which migrate the database, create the users table, and this seed script, which creates two dummy users. You can actually set up the credentials here to your local and test it and run it on your machine before we run it on Docker to get an idea on how it works. I'm going to skip that part because I don't want to make the video extra long. So I'm going to recreate the Docker file. So here I'll create a file. Let's call it Docker file again. Actually, I should have kept it because it's almost identical. So here we'll say from node :15, and here we'll do our work directory, and this is /app. And here we'll copy everything. So copy dot to dot, and we'll do our run npm install. And we'll do our command, and here actually I'm going to say npm start and save, because if you see at the package.json we have npm start, which starts our server.js, so we'll use that. So we need to create a Docker container that has Postgres engine on it so that we can connect to it and manage our data there. So let's go to Docker Hub and search for Postgres, hit enter. And we get here this most popular image just named Postgres. And we can scroll down to see some extra flags on how to use this. So there we go. There's an example here, Docker run, and then you give it the name, just like we did. And here there's this -e, which sets an environment variable. And in this case, you can set Postgres _password to set a password for your default user. So we can actually just copy this. So copy all of this. And then let's go to the terminal and paste that. I'm going to rename the name. So here we'll say, I think I have another Postgres container, so I'll call this post Postgres-docker. And for the password, let's set it to 12345 and it's detached, but I'm gonna add something extra. I'm gonna add -p so that we can access it from this machine right now. So the internal one, the one on the right, I'm gonna expose the internal port 4532, which is the default Postgres port, and I'm gonna expose it as 4321 just to show you how you can use it differently because it's easier to understand that way. And now let's hit enter. It doesn't find Postgres locally, it's gonna download the image from the web, so I'll wait for that. And there we go. Just as easily we have Postgres running. And to prove it, now because I have Postgres installed, I can actually connect into it. But even if you don't have Postgres installed, you can do that. So using PSQL, we can say PSQL and say, actually we don't need to say the database, or actually we do. So we'll say -d Postgres because that's the default database that's created. And here let's say -h for host, and this will be on this machine, so localhost, and then say -p to give the port. And this will be 4321 and hit enter. And now asks us for the password. Okay, so ask me for password user class. That's wrong. I'm just going to exit because the user by default is Postgres. So I'm going to add the flag -U Postgres and hit enter. And now I'm going to type 123456 because that's what we set. Hit enter. And there we go. We have Postgres installed in this container and we can access it. We can list the databases and we can see them there. And now we can, oh, actually exit worked, cool. And even if you don't have Postgres installed, you can just open a terminal inside that container by saying docker exec -it, and we called it Postgres-docker. And you can run, actually you can straight away run PSQL there and hit enter. Okay, raw root does not exist. So we can add the flag -u Postgres. And there we go. We don't need the password because we were running it from inside the machine and we have Postgres. Cool. So let's connect our app with this Postgres database. So actually just to test it, I'm going to say npm install, and here inside db.js, let's replace the credentials here. So the user is Postgres. The password is 1 through 6. The database, I'm just going to set it to Postgres. Actually interesting. I don't know if this takes support. I think it does. Yeah. So let's say port 4321, save. And now this should actually connect. We can test it by running the migrate script. So npm run migrate, hit enter. There we go. It says user created users table. And to double check, we can execute the PSQL command inside the container again, and then list the tables \d. There we go. We get the users table. So our app on our machine is connecting to this Postgres inside of this container. Now the next step is to build this app into a container and then have those containers talk to each other. Now there are two ways. Way number one is a bit dirty, to be honest, which is to expose the ports like we did here and then have that container talk to it through our machine. Way number two is better, which is to create these two containers together inside one network, which is another concept that we're going to touch on now. That way they can talk to each other without exposing any ports. We can do this through the terminal, but I'm sick of typing like docker run -p like it's a lot of like flags, okay? So we can use something called docker compose, which allows us to write this stuff one time and then not have to worry about it again. So how does that work? So let's create here a new file, call it docker-compose.yaml. And the docker compose is a file that has instructions on how to create multiple images for multiple services, which are containers that we need for a certain project. For this, we need to set a version. And right now the latest version is 3.9. So I suggest you use the same in case in the future it changes and you'll have some problems. So for this, you should use the same as I'm using, 3.9. And here we're going to say services. And this is a list of services, aka the containers that compose our project. So first here, I'm going to call this server. And be careful with indentation because YAML is very strict. If you make a mistake in indentation, it's not going to be able to parse it properly. And here to build this image from this Docker file, we can simply say build, and the value will be dot, which will tell it to look for the Docker file inside of this directory. And here we can say ports, and these are a list, so we can expose multiple ports, but we just need, so put these in quotes just in case it has problem parsing special characters. So here we'll say 5000:5000, so we don't have to type it in the terminal every time. And that's it for the server, for the node server image. Now let's go back to indentation spaces, and here let's put the container for the database, and I'll just call it db. So here, we're not going to use build. We're going to use image, which takes an image from the web or even locally if you have it, because we don't need a Docker file for it. It's already made. So here, this will be a string and this will be Postgres. Now, I want to give it, because for this Postgres, we gave it earlier a Postgres password. I want to give them through here. And to do this, you can use environment, and here you can pass as many environment variables as you want. So let's check the docs again. Yeah, so it's this Postgres password. So here, go back and do Postgres password. And then this will be, let's set it to the same 1 through 6. And we can also set, what can we set? Let's see. Yeah, we can set a default user. And based on this default user, a default database with the same name will be created. So here, for example, we can say Postgres user and we can call this Docker. And here actually we can do the ports as well. So here we can say ports. Here that we're going to expose to 4321. We're going to expose 5432. So save. And now let's go back to our terminal. I'm actually going to remove that existing, actually both these existing containers. So I'm going to take their ID. So here we'll say Docker stop and paste this. Actually, can we stop 2 at once? I think we can. So -t0, run that. Cool. Yeah, it stopped both. And now I'm going to remove both. So here Docker rm. And that's gonna remove both. Cool. So let's check images. I'm gonna remove both these images just to have a clean slate. Probably for you, it's gonna be empty when you remove everything, so it's easier to tell which is which. And also it's good to practice these commands so that you remember them. Repetition is practice and practice makes perfect. So here, Docker rmi to remove images. And I'm gonna remove node-server. And can I tag this by ID and this by name? So paste that. Cool, so it removed those images. Now, to build these services in this Docker Compose, we can simply say docker-compose up. And here let's do -d so it starts in detached mode. And there we go, it's building server. So that's done. And notice it doesn't say building Postgres because that image is already built and it's on the web. And there we go, it's created these 2 containers. And it's given them the name or the prefix Docker tutorial because it's the name of the folder that they're in. And we have db-1 and server-1. Let's check if this is working. Let's run a command to migrate the database. So let's say docker exec, and we're going to execute this on docker tutorial _ server-1 or whatever the name of the container for you. And we're going to execute npm run migrate, then hit enter. Okay, we get an error and let's see, error connects refused. Okay, so it couldn't connect to the database. That means it couldn't connect to the other container. So, oh, okay, my bad. I forgot to change this. This is localhost. This shouldn't be localhost because on that machine, localhost is that container itself, which the database is not there. Now, one nice thing, one piece of magic that Docker Compose does is we can here say just db, which is the exact same name as the service, and Docker in the background is going to replace this db with the address of that container, which is really nice. And also, we're not going to use this port. We're actually going to use the default port of Postgres, and I'll explain what happens in a second. So let's rebuild this. First, let's remove those containers, and we can actually say docker-compose, and we can say down, which will remove those, we will stop those containers and actually remove them, which is really nice. We don't have to manually remove them. So if we do that docker ps-a, as you can see, those Docker tutorial beginning containers are actually gone. But the image is still there because the image is important. You don't want to delete it this way. You want to always delete it manually, which is the proper behavior. So to rebuild this, we can say docker-compose up. But if we do this, it's actually going to start the containers based on this existing image. But we can add the flag --build and again add the -d. And what the --build does is going to check if anything has changed, which indeed it has. And then it's going to build it if there's some differences. So now if we run this, it's actually going to recreate the Docker tutorial server image. And now if we do docker exec and run the command on this Docker tutorial server 1, and we run npm run migrate and hit enter. Okay, we get another error. Okay, my bad. So another mistake. I forgot to change the username because in the Docker Compose, we set it to be Docker. So I'm just going to change this to Docker. And the database will be Docker as well because there's a database created based on the username, like I said earlier. So, okay, so I'm just going to rebuild it again. So change that. And let's do again Docker Compose down. And again, let's rebuild. So docker compose up dash dash build dash d. And third time is the charm, so this time it should work. So now if we execute the same command, npm run migrate, there we go, it created the users table. And we can actually in a different terminal check again. So let's do psql-p4321-d docker-u docker and hit enter, and the password is 1 through 6. And if we list the tables, we see that there is a users table, and if we select star from users, it's empty. And now if we run the seed command, which creates 2 users, we get added dummy users, and if we select the data, we see that there is data added to that table. So we're able to connect to that container with the database from the container with the server. And if we do curl localhost 5000/users, we get our users. And we can actually add users. So we can do a post request. We can say curl dash uppercase X to give it a method, and we'll say the method is post. And we can say dash D to send some form data. And here I'll say name equals Ahmed to add my name on the list, and then execute this. And then if we fetch /users again, we get Ahmed is added to the list. And if we check again in that database, Ahmed is added to that database. So we're able to interact with it through the API as well. So that's cool. Now, there is a little problem with this, which is if we run docker compose down, it's going to stop and remove our containers, which is a problem in this case because in our database is stored inside the container. Now, we can leverage a concept called volumes in Docker, which is a separate directory where Docker will store certain files that you want to have persisted. In this case, we want to create this container with our database, but we want the data in it to be persisted and not removed anytime we remove that container or even the image itself. So how do we do that? So let's go back to the Postgres, in Postgres image in the Docker Hub, and we can scroll down. Yeah, so here it shows us an example where they run a Docker container based on this image, but pay attention to here, there's -v. Actually, let me zoom this. So there's -v, and then it gives it, and then they give it a path, custom path, and then colon, and then they give it this path, which contains the data of the Postgres engine or server. We can do the same through the command line, or we can also do it on the Docker Compose file. So we can go back to the Docker Compose, and here for this DB server, we can add another key down here on the same level as environment, and we can say volumes. And this is usually a list, and here I'll call this data and do colon / and then we're going to actually paste this path. So copy that and paste it here. And actually here I'm going to declare another volumes key, which is the volumes for the entire network. So here we'll say volumes and we'll say data, and I'm just going to keep it like that because we don't need more info. And by the way, we can remove this port from here because we don't need to export this port or expose this port, because by default in Docker Compose creates a network that allows these services to talk to each other, and we don't need to access the database from outside, so we can keep it locked like that. So save this and let's go back to our terminal, and now we can say docker compose up -- build -d, hit enter, and now you see first thing is it created the network. It did that already earlier as well. And now it created a volume, docker tutorial _ data. So now we get exactly the same thing happens, but let's say, can I find that command? Yes, let's run the npm run migrate to migrate, and then let's run seed, and then let's run, actually let's fetch the data. You'll see that it's of course reset to the dummy user's data. Now let's run the command to create a user, and I'm going to add myself, and I'm going to maybe add, I don't know, another user, maybe Chris. And now we have 4 users. But now if we say docker -compose down, and if we remove the containers, the data will still persist. And where does it persist? It persists in, let's do docker volumes ls, actually not volumes, volume ls. And you'll see there are a couple of volumes that are not related to this, but there is this one volume which contains the data for our Postgres database. So to prove this, we can actually just run it again. So we can, where is it? Docker compose up. We don't need to do -- build because we didn't change anything, but we can still do it anyway. So hit enter. Cool, everything is created. And if we run curl localhost 5000/users, we're gonna get that data, and it's the updated data. So our database data is actually persisting and not removed anytime we remove the container or the image itself. So this is a really cool way to preserve your data. There's a lot more to do with Docker, with deployment and using things like Kubernetes for orchestrating complicated projects with many images, but I believe this information that you have here is more than enough to get started and to use it in a useful way for your projects, and of course not too much that it overwhelms you and you don't even retain any of it. Alright, that's it for this one. You'll find this code in the same repo, but probably on a different branch if you need access to it. And please, again, make sure to like this video. It really means a lot and helps get the channel growing. And of course, subscribe if you haven't done so yet. And I will catch you in the next one. Peace.